All right, let's graph these exponents today, see what they look like. Kind of got a glimpse of that with the activity that we did last week in class. I'm just going to graph just a basic one that has, I'm just going to make up a growth factor here, just b, and not worry about that initial amount that we have. Okay, so if b is positive, the graph is going to be going up this way, okay, up to the right. Now, on all these that we're going to be doing tonight, as you can see, the domain is going to be from negative infinity to infinity. Okay. On this one in particular, though, this one comes down and it almost touches the y-axis. It's really close to it, but it doesn't quite touch it, making it so the range is 0 to infinity. And on the basic parent function, the only time it's going to touch an axis is at the point 0, 1. I think I've already said the isotope is going to be at y equals 0, or simply the x-axis. So here's my basic rundown of what I think needs to happen whenever we're graphing these. What I want to do is I want to make a table of values. Okay, and I'm going to use at least 3 points and be very specific with the 3 points I want to make it easy on us. Draw a smooth curve, and then we know our domain, range, and horizontal isotope. So whenever we're graphing f of x equals 5 to the x, what I want to do is I want to make an xy table with it. And the 3 points I want you to use, and I'll be consistent with this for the rest of this unit, will be -1, 0, and 1. These numbers are pretty easy to plug in. Use your calculator if you need to, but 5 to the negative first power is 1/5. Anything to the 0 power is 1, and then anything to the first power is itself, giving me these 3 points. -1, positive 1/5, 0, 1, got a dot, not an x. 1, 2, 3, 4, 5, right? Draw a smooth curve through these 3 points. I missed that last point. Oh well, get the idea with it. Domain, this thing is touching everything to the left and to the right. So we'll say negative infinity to infinity. And then the range is sitting on the x-axis, so it would be 0 to infinity. And the isotope has that meters. That isotope's going to move in just a minute. So I'm going to be, on the rest of these examples, I'm going to be in and out doing the domain and range on some of these. Homework won't ask for all of them, just on some of them. So I'm not trying to be inconsistent on the video, but just trying to save some time. So let's see what happens with this one. Now, I just erased it, but I purposely am picking on this 5 to the x right here. Because that last example, I don't know if I'm allowed to say this, but it was kind of easy. Most of the time when my students say something's easy, they get upset with me. And so that gives me a 1/5, 1, and 5, just like on the last time. And so what I'm going to do with this is I'm going to come over here and I'm going to plot these points here. But we have that -1 that I purposely left outside of the box. And this gets back to our idea of transformations. And that -1 is inside the function. And the reason I know it's inside the function is because it's inside the exponent. When it's inside the exponent, that's going to cause it to move left or right. So I'm thinking move it to the left in this -1. But remember, everything inside the function is backwards. So it's going to move it to the right one. So all these little x's are going to come to the right one. And the isotope, it comes to the right one as well. Moving a horizontal line to the right one doesn't really move it a whole lot. So I get the same graph that I had on the last one. It's just been moved to the right one. Everything's still the same on it. The domain, the range, and the isotope is still at this point y. So I gave you one pretty similar. I want to see if you can notice the difference on this. Go ahead and graph it, and then hit play again on the video and see if your graph matches mine. And on this one, the -1 was outside the function, so I took those original x's, moved everything down one. Notice what that did to my range. Oops, my range and my isotope. Range changed to -1 to infinity, isotope. These numbers should match on the range and the isotope. Hey, let's change it up just a little bit. You could probably do this one on your own, but just going to get rid of that 5 in parentheses, take it to something else. Now, you're going to hear me refer to this. I've been referring to it for some reason as stripping this down to its skimpies. Okay, the only thing I'm really wanting is y equals my growth factor to the x power. That's going to make it so that when I do my xy table and I plug in -1, 0, 1, it makes it so it comes out really easy for me. Okay, then I'm going to go ahead and come over here and plot these points. So I can just do transformations on here, here, and here. Now this time, let's think about what these transformations are going to do. We kind of combine the last two examples. +4, I would think move it to the right 4 since it's inside. Remember, it's opposite, so everything's going to move left 4. And then this +2 is big. It'll move everything up 2. So all these little x's have to go left 4, up 2. 1, 2, 3, 4, and up 2. 1, 2, 3, 4, and up 2. 1, 2, 3, 4, up 2. Now the isotope doesn't want to get left out on this. It wants to move left 4 and up 2 as well. Moving it left or right doesn't really matter. So this would be my graph of it. Domain, just like every other time, -infinity to infinity. The range, well, it's sitting on 2. It's not quite touching 2, but it sits on 2. So the isotope is where it's sitting, y equals 2. See if we can hit a different type of transformation on this. You can see nothing's being added or subtracted from this one. Rather, it's being multiplied. See if we can make sense of what this was doing. Again, stripping this down to its skimpies. The one thing I want on there is the b raised to the x. I don't want the a on there. So the b raised to the x, that's going to give me an xy table. Let's see, 1/3, 1, and 3. So here, here, and here. So I can kind of see that slide that it's taken on. But this 1/3, it's outside the function because it's outside of the exponent. And it's being multiplied. Whenever it's multiplying, that's either a compression or a stretch. In this case, it's going to be a compression because it's less than 1. So I'm going to take all these blue x's right here, and I'm going to squish them by a factor of 1/3. I had one young lady this morning said, well, why can't I just come in here and just multiply all these y factors by 1/3? Yeah, that's exactly what we did a couple months ago. You can do that. That was going to be kind of hard to see. 1/3 and 1. And so my graph has just been squished down to this red line. Domain would still be -infinity to infinity. Range is 0 to infinity, and the isotope is at 0 since it did not move. You tried this one with, we've got two things going on with it. See if you can get it to match up to my answer. I almost messed up on this one and did not move my isotope down 1. But I stretched it by a factor of 3 with the x's, the red x's, and then moved it down 1 by the green line. Green line being my final answer. All right, one last transformation we haven't talked about yet is a pesky negative sign. So, still stripping it down to its skimpies here. y equals 2 to the x. So I have the same table as last time. You would think eventually I would quit erasing my table. Good grief. Okay, so we're here, here, and here. Order of operations applies on this. So this is kind of a grouping up here in the exponent. So the first thing I'm going to do is I'm going to go ahead and move everything to the left. Okay, so it's going to be 1, 2, 3. Here, 1, 2, 3. then that negative sign, it is outside the function. Don't think of it in terms of x and y. Think of it outside the function. Everything's going up and down, including reflections will go up and down. So my reflection is going to come down to here. Give me a graph. Number one wrong thing people do is they try to plug in this -1, 0, 1 into the whole thing without stripping it down to its skin piece. That will work sometimes. I don't want to tell you it won't work. But like on a problem like this, by the time this graph reaches -1, 0, and 1, it's going to be way down here into the negatives. And so I want you to be careful that you don't, I want you to be careful. I want you to strip it all the way down to its basic parent function and then do all of your transformations. So domain on this is the same domain as always been. Look at the range. Range turned around on us and went negative infinity to 0. So the isotope is still at 0. Again, pick that number out of the range and that will match up to your isotope. They did have some where you work it in reverse on this. I'm going to skip the domain and range for now on this because we have been, I feel like I've been beating that to death. Instead, what I'm going to do is I'm just going to take this f of x equals, there's Euler's e to the x. And it just tells me each individually what's happening to the graph. So first up, it says it's been stretched by a factor of 2. Don't put a +2. And it's a vertical, so it goes outside the function. Reflected across the y-axis. Well, my y-axis is the one that goes up and down. So if I reflect it, it's reflecting left and right, which will put a negative inside the function. And then 4 units up, there's a vertical shift. 4 units up. If I needed to, I could still get the isotope. We know the isotope is going to follow the domain and range. And if everything came up 4 units, that means the isotope came up 4 units. Meaning that the range would be 4 to infinity. And the domain is the same as it has always been. Okay. All right, that's kind of a rundown on it. I know you did a lot of work on your own on that, but hopefully that makes sense. And I got kind of a summary right here if you want to pause the page, and just a summary of the transformations that we did back in the second unit. And there's your homework, please. Let me know if you have any questions.